Today we are going to finish our discussion of the chapter 12, and this is also the last chapter this semester. And on the Friday, I'm going to provide you the review sections. And in this review section, I will try to help you to cover and or refresh your memory of some important concept. But please remember that the final exam will not depend only on the review sections. And for the final exam, the chapter which you are going to be covered is the chapter 8, 9, 10, 11, and 12. Only 5 chapters. So you don't have to go back and study the previous 7 chapters. So I hope this will release some burden from you. So in our previous discussion that we have studied the spectrums produced by atoms. So the typical spectrum is like this. It is composed of a bunch of the discrete lines, and each line has different kind of frequency, and each element will produce their own spectrums. So you can basically treat that the spectrums produced by the element is a fingerprint for that. So what I did not explain is how does the spectrum was produced. So since when the energy was provided to electrons within the atoms. So this is a nucleus and this is one of the electrons. So if the energy is provided, then this electron will be excited and jump to another orbit, which also circling around the nucleus. So when the electron jump to a higher energy orbit, then later on he will jump back to the lower energy level because it is unstable there. So when the electron jumping back, he will release an energy, and this energy will be released in terms of the light, which is the radiation, which is the EM wave, depending on what you want, which term you are familiar with. So for every single jump back movement, they will produce a line here. And why it is discrete, not continuous? It is because that the energy level for different orbit is also discrete. You will not see any energy orbit between these two. So therefore, they can only jump back to this one and jumping back to the lower one here. So this kind of jumping back and forth process is discrete because the energy release is only for a fixed number of the energy. So this is a concept of the excitation of the electrons within the atoms. So now let's have our first conceptual quiz. So each spectral line in the atomic spectrum represents what? So apparently, based on our knowledge, it represents that a specific frequency of the light emitted by the electrons. So for every single electron jumping back, they will emit a photon. So it is related to the frequency carried by this photon. Okay. So today we will have more than one on the conceptual quiz without answers. So let's have the second one. So this one, I will not provide you answers. So please email me your answer with the explanation after watching the video. So now let's have the third one. So when the atom is excited, what will happen? So the answer should be A. So the energy will be released to the electrons. So the electron will be excited and jump to a high energy orbit level. And later on, the electron will jump back. But no matter what, when the atom is excited, what happens is the electron will be jumped to a higher energy level. So now I hope these pictures can summarize a simple physics behind why the discrete line was produced when the electron was excited. So now we are getting to the most important thing in the modern physics. So we are going to study the so-called quantum hypothesis. So what is the quantum hypothesis? This is the first time proposed by the Max Planck. He is a very famous physicist, and his main contribution is that when people try to study the black body radiation, do you remember that in the chapter 10 or 11, we have the study about the color produced by a so-called black body. So if the light was trapped inside, then which means all the energy was absorbed, then it looks black. So after the time passes through, the energy will be absorbed and they will hit the object. So the temperature of the object will increase and then they will radiate the light off. So the light is a so-called black body radiation. So at the very beginning, the people had trouble using the knowledge from the classical physics to explain the result from the black body radiation. So they cannot really fit the curve. So Planck is the first one to say that now I can successfully fit the curve by simply assume that now the light, the black body radiation is not continuous. Instead, it is quantized. And each quanta has a discrete energy. So the picture now was broken into from continuous to discrete. So intrinsically is that a beam of light is not a continuous stream of energy. Instead, it is a matter of a lot of small discrete quanta called a photon. So the general picture here is that for this continuous stream of energy, it is the wave. So the light can be described by the wave. However, in order to explain the concept of the black body radiation, the wave concept is not enough. So you have to quantize the wave, and the quantization of the wave is the photon as a particle, and each photon carries a specific energy. So this is the concept of a quantization. So now we find out the light has a wave property and the particle property. But at the very beginning of history, even though the Planck can successfully explain the black body radiation, the science community do not widely accept his theory until the early 20th centuries when Einstein proposed photoelectric explanations based on the Max Planck assumptions. Then finally people start to accept the concept of quanta. So the question now is the light a wave or a string of particles? So based on the quantum physics, light can be a particle or can be a wave. This is a concept of the duality. So this concept is so-called the de Broglie hypothesis. So the most important concept for this hypothesis is that originally we say that the light is a wave, but intrinsically they carry the property of the particle. So the quantum hypothesis also tells us is that now if you, for example, as a human being, our behavior is more like a particle, but intrinsically we also have a wave property. So you definitely at this moment you will start to say, it sounds crazy. How could it be that I as a human being can be described by a wave? So the reason the wave property of you as a particle is not obvious is because the wavelength you produce is too long. And we learned that from the chapter 10 and 11 is that when you produce a very long wavelength, they will not be reflected by any object. So if it cannot be reflected or refracted, then there's no way you can see the effect of that. So therefore, you will simply say that I, as a human being, I behave more like a particle, but intrinsically, you also have your own wave functions or the wave property. So the quantum hypothesis tells us that no matter what kind of object, they simultaneously have the wave and the particle properties. And now let's go back to the quantization of the light, which is a photon. So the energy carried by the photon is proportional to the frequency of the light. So you see, the frequency of the light is a concept of wave. So now they can be used to describe the energy of the particles. So this duality now are connected together. So this is a very important concept. So the higher the frequency, the bigger the energy carried by the photon, which is the light. But we know that the the EM wave is, there's a spectrum for the EM wave. They all have a different kind of frequency. So they all have the same speed of light, but the frequency is different. Okay? So the energy doesn't depend on the speed of light, or doesn't depend on the wavelengths. They depend on the frequency. So now let's have our fourth conceptual quiz today. So in this relationship, the E is approximately the frequency carried by the photon. So what does the E means? So here, please think carefully when you try to answer. So this will be the second unanswered questions today.